Welcome all of you again to PHARMA. Yes, this is the online GPAT preparation video according to the latest GPAT syllabus. Here we will discuss about important pharmacy mathematics for graduate pharma aptitude test. So कौन सा मैथ आता है आपका GPAT एग्जाम पे वो लेके हम यहाँ पे थोड़ा डिस्कस करेंगे. Okay, so today the topic is calculation of ionic strength of solution. Okay. So this is the MCQ type questions. So here we will go through some math and we will discuss all the maths along with the answer. So question number 1, find out the dissociation factor of sodium chloride, that is the NaCl, when it dissociates 70% in water. Yes, so they are asking find out the dissociation factor of sodium chloride which dissociates 70% in water. So options are option A 1.4, option B 0.3, option C 1.7, option D 0.7. So how to solve the problem? So to solve this problem we have to remember one formula. The formula of dissociation factor is that dissociation factor equal to total number of particles after dissociation divided by number of particles before dissociation. So what do you mean by dissociation factor? The dissociation factor is equal to total number of particles after dissociation divided by number of particles before dissociation. So dissociation के पहले कितना पार्टिकल था और dissociation के बाद में कितना पार्टिकल. Okay, so dissociation factor is dissociation का बाद में कितना पार्टिकल है divided by dissociation का पहले कितना particles था. So dissociation factor equal to total number of particles after dissociation divided by number of particles before dissociation. So here according to the questions, the question is asking that 70% sodium chloride dissociates. So suppose before dissociation total number of particles of sodium chloride is 100. Okay, so after dissociation 70% dissociate. So if sodium chloride dissociates it will provide sodium plus and Cl minus. So after dissociates, let's 70% dissociates, that means 70 particles of sodium plus and 70 particles of Cl minus, and total there was 100 particles, and after dissociation, after 70% dissociation 30 sodium chloride particles will be remain intact. So total number of particles after dissociation equal to 70 plus 70, that is 70 sodium plus 70 chloride and 30 sodium chloride. So total is 170. So dissociation factor equal to, according to this formula, dissociation factor equal to total number of particles after dissociation, that is 170, divided by total number of particles before dissociation, that is 100. So 170 by 100, that is equal to 1.7. So correct answer is 1.7. So the dissociation factor is 1.7. Next question, find out the dissociation factor of sodium carbonate, that is Na2CO3, which dissociates 80% in water. So options are option A 2.6, option B 0.8, option C 1.8, option D 0.2. Okay, so according to this question, sodium carbonate dissociates 80% in water. So just let before dissociation there was total 100 particles. Yes, so after dissociation sodium dissociates 80, it will give 80 particles of sodium. Okay, so there is Na2, that's why 80 into 2, that is 160 sodium ion will be present. Remember this is Na2CO3. Okay, so Na2 means 2 Na, so 2 mole of sodium will be present. So 80 into 2, that is 160 particles of sodium will be present, and carbonate ions will be present, CO3 will be present, 80% dissociate, that means total 80, and undissociated sodium carbonate. 80% dissociate means 20 particles is not dissociated. Okay, so total particles after dissociation is equal to 160 plus 80 plus 20, that is 260. So as we discussed the formula, dissociation factor equal to total number of particles after dissociation, that is equal to 260. If we summation of this 160, 80 and 20, that is 260, divided by total number of particles before dissociation, that is 100. Okay, so 260 by 100 equal to 2.6. okay, so dissociation factor is 2.6. so correct answer is 2.6. so here Na2 is there, that's why we multiply, and dissociation factor is 80, so that's why we multiply 80 by 2. But in the previous math, that sodium chloride was there. Okay, so there is no case of multiplication. Okay, next question 3, find out the dissociation factor of magnesium sulfate which dissociates 50% in water. So options are A 1, option B 1.5, option C 0.5, option D 2. So correct answer is 1.5. so the dissociation factor for magnesium sulfate which dissociates 50% in water is 1.5. so how to calculate? As we discussed earlier, that is the dissociation factor equal to total number of particles after dissociation divided by total number of particles before dissociation. Okay, now magnesium sulfate dissociates 50%. so let before dissociation there was 100 particles in the solution. Okay, so number of particles before dissociation is equal to 100. After dissociation, the magnesium will be dissociated as Mg plus. So Mg plus ion will be 50 as 50% dissociates, and sulfate ion will be 50 at 50% dissociates, and undissociated MgSO4 will be 50. Okay, so total after dissociation total particle is 50 magnesium, 50 sulfate, and undissociated magnesium sulfate is 50. so total 50 plus 50 plus 50 equal to 150. so after dissociation total particles present is 150. so dissociation factor equal to 150, that is total number of particle after dissociation divided by total number of particle before dissociation, that is 100. so 150 by 100 equal to 1.5. so correct answer is option B. Okay, clear? Thank you. So if you like our video, if you want to go more preparation for GPAT, please like PharmaDis and please subscribe PharmaDis. Thank you.